Hello Year 12s. This video is for Learning Intention 34, which is all about solving definite integrals. And this is for Learning Intention 34. We're up to 34. The year's just flying by. And the result, like the theorem in maths that says you can do what we're about to learn, is a very big deal. Like, it's a really, really big deal. And I want to show you the book's attempt to explain it. The book has a go at defining this stuff formally, and going through and explaining why this all occurs, and it all looks like a bunch of nonsense. That's because it is. They make a huge assumption here. They say let f of x be the function that is the measure of the area under the curve between a and x. That's really important. So they've kind of, I don't know, they've assumed the theorem essentially. It's like, yeah. My point is, don't bother reading this. Don't read from there to there. Don't read those. Read this. This is good. Read there onwards. Just a warning. If you're going through and you want to have a read, don't read it. Don't bother. Don't waste your time. Solve definite integrals. Well, let's remind ourselves of some things. I'm going to have some reminders down here, just so we know. So these are things you should know from last year. A definite integral is one that has terminals. So this is a definite integral. This is definite because it has these terminals here. It's indefinite if it doesn't have the terminals. So this is indefinite. A definite integral will generally spit out a number answer. Like, it'll just spit out like 6 or something. Like this one is going to be, I don't know, let's do it. X squared on 2 from 2 to 1. 4 on 2 minus a half. So this is going to be 3 on 2. Whereas this one spits out blah, blah, blah plus c. So a definite integral will spit out a number. Indefinite integral splits out some variables plus c. And I've put this important fact here that you should know, that if you flip the terminals, you can flip the sign and you'll get the same answer. So I'm going to take this, I'm going to flip the sign, I'm going to flip the terminals, and look what happens. Equals x squared on 2 with a negative out the front, 1, 2, equals a half minus 4 on 2. Well, a half minus 4 on 2 is negative 3/4. Sorry, negative 3 on 2. Negative 3 on 2 times minus 1 is 3 on 2. So flip the signs, flip the terminals. We should know these things. I'm hoping we've got those down. That should be a reminder. Alright, what about over here? Let's do some tricky examples. Let's call this example 1. Alright, so a definite integral should spit out a number. So the first thing we're going to do is integrate. So we're going to integrate each term. We have x squared, so we add 1 to the power, divide by the new power, plus 3, it's going to be 3x, minus, oh, now we've got this sine business. Okay, well, sine diffs to cos, so cos integrates to sine, so this is going to give us a negative somewhere. So keep the negative 6 out the front, the constant stays out the front, and then we're going to have negative 1/3 cos 3x, like that. Alright, if I'm unsure about that, so I'm going to check that. Well, this should all diff to negative 6 sine 3x. Let's do a quick check, because I'm not sure, and I'm a good student, so I like to check these things. Well, negative 6 times negative a third is 2, so we're finding the derivative of 2 cos 3x. Well, cos diffs to negative sine, so that becomes negative 6 sine 3x. Good, okay, that is that. Negative 6 sine 3x. So we've done the correct integration there. And then you do your big brackets and you put your terminals out the front there, the 3 and the 1. Alright, let's tidy it up a bit. We've got x cubed on 3 plus 3x plus 2 cos 3x. And we've got 3 and 1 as our terminals. So if you remember, you sub in the 3 and then minus with the 1 subbed in. So sub in the 3, so that's going to give you 3 cubed on 3 plus 3 times 3 plus 2 cos 3 times 3 is 9, 2 cos of 9 minus 1 cubed on 3 plus 3 times 1 plus 2 cos of 3. Alrighty, this looks nasty. This is 3 squared, which is 9, plus 9 is 18, plus 2 cos of 9 minus a third plus 3, which is 3 and a third, which is 10 thirds, plus 2 cos of 3. Alright, well, 10 on 3, and we've got 18, so that's the same as 54 on 3, plus 2 cos of 9 minus 10 on 3 plus 2 cos of 3. So that's 44 on 3, because I've gone 54 on 3 minus 10 on 3, plus 2 cos of 9 plus 2 cos of 3. And you can't simplify that any further. That's a number. That's some number. What will the cas do? Well, we can find out. Let's grab the cas and shift plus. Whoops. Got to make sure I actually press shift. Did I press shift? There we are, shift plus. Now we put in the terminals. So 1 goes there, and up you go. Come on. It's being really stubborn. Like that. Alright. Is that frozen? Not sure what's happening there. Anyway, that's your final answer. So, as an exact value, if you asked for, let's see what the book wanted for that. So that was, I took some tricky ones. The book says find the exact value. Yep, without a calculator. So that's what it would expect from you. All right, let's have a look at number 2 here. Solving definite integrals. Let's have a look at number 2, and yep, I'm always going to chop off a bit of my heading. Number 2. Number 2. Let's see what this gives us. So we need to integrate. 1 on x, we know integrates to the natural log of x. Natural log of x. And this cos business, here we go. So cos must integrate to sine, because sine diffs to cos. So it's going to be sine x on 2, because whatever's in the bracket stays the same, but we're dividing what's in the bracket. So we're taking the coefficient of x, which is a half, and we're going 3 divided by the half, which is 6. And let's put our terminals there, pi and 1. Let's check if we're right. What's d dx of 6 sine x on 2? Sine diffs to cos, and we take the coefficient out the front. So it's 6 times a half cos x on 2, which is 3 cos x on 2. So I just did a mental check. Yep, did a mental check. That's good. So that's my kind of mental check, but I've done it. I've written it down. So let's sub in the values. Let's see, what do we got? Natural log of pi plus 6 sine pi on 2 minus natural log of 1 plus 6 sine of a half. Let's simplify. Natural log of pi, that's just some ugly number, just leave it. It's the natural log of pi, you can't simplify that. Pi on 2, sine pi on 2. Well, our unit circle, pi on 2 is here, and the y value is 1. So sine of pi on 2 is 1. So that's plus 6 minus natural log of 1, which is 0, plus 6 sine of a half. Sine of a half, don't get tripped up here because you might think of exact values here. Well, no, because it's sine of a half. Sine of a half is some number we don't necessarily know. Sine pi on 6 is 1/2. So sine pi on 6 equals 1/2. But sine of half, we're just got to leave it. Well, our answer is the natural log of pi plus 6 minus 6 sine of a half. And there's our answer. Can't simplify it any further. That's the integral for number 2. Those are tricky ones, so go through the exercise, see how you go. Don't forget this fact. Please memorize this, that you can, if you flip the terminals, you flip the sign. And if you have been, thank you for watching.